All right, it's time for some thermochemistry. As you may have guessed, the word thermal, the part thermo relates to heat, chemistry relates to matter. So when you study heat changes within matter, we call it thermochemistry. Okay, the very fundamental thing you need to do before you do anything in thermochemistry is have a perspective change. You have been studying thermochemistry all along when you study the temperature of objects, when you state whether a reaction is absorbing or releasing heat energy. But now the terms that we're going to use in this unit, you need to make sure that you have some perspective change. And by that, what I mean is, so far, let's say if you're looking at a beaker, a reaction happening within a beaker, you were looking at it as an outsider, right? Whether you whether it was intentional or unintentional, you were looking at things from the surroundings perspective. Whatever happened in the beaker, you looked at it from the outside. If it released any heat, you were able to touch that beaker and tell if it released any heat or not. If it absorbed any heat, again, you were able to touch that beaker and say that if it feels cold, then it absorbed heat, right? Now, if you want to be able to succeed in thermochemistry, the very first thing you need to do is forget, or not forget, but include with the surroundings perspective of the system as well. There will be a lot of the terms that you'll be using that will be from the perspective of the system. Okay, so imagine that you're diving into that beaker and you are inside that beaker, okay, and you're a part of that system. To be able to understand this better, be a part of the system. There are three types of systems that you can get from the perspective of thermochemistry. One is an open system. Another is a closed system. And another one is an isolated system. So let's make sure we understand the difference between these three. When you talk about an open system, what I've drawn here is an open system where you can add or remove things. If this reaction, let's say there was a reaction happening that produced gas, it would be able to easily escape, right? So matter can escape in form of gas or liquid, and energy can escape. When you touch it, it feels hot or cold depending on the type of the reaction. So an open system is one in which matter and energy can escape. There are no limitations. Okay, to make it a closed system, all you'd have to do is put a lid on top of this. Let's say this was a lid. Once you put a lid on top of that container, now those gases are not able to escape. Any water vapor that's created will not be able to escape. You can observe that if you cook, when you pick up that lid, you'll see some water vapor just condensing there. So it did not leave that system, right? So a closed system is one in which matter cannot escape. But does that prevent energy from not escaping? Is it that when you put a lid on top, somehow magically energy also doesn't leave? That's not true. Even if you put a lid on top, if you touch that container, it will be hot or cold depending on what type of reaction there's happening. So a closed system, matter can't escape, but energy still can escape. Okay? So to make that energy not escape, we need an isolated system. Okay? We need a truly isolated system. Now, a truly isolated system actually does not exist, because it doesn't matter how isolated you have, even if you have a nuclear reactor, you're trying to keep record of each and every joule of energy being produced, you'll still have some energy that will be lost. So a truly isolated system is almost impossible to attain but you can try to reach close to it. To make this system a little bit less closed, I would say, and more isolated, all you'd have to do is put insulation around that beaker. If you put insulating material around that beaker so that it is not as easy for energy to escape. And for that insulation, you can use any of the materials that we use generally. For example, if it's a hot cup of coffee, it would usually have either thermocol material or styrofoam associated with it that will help you not have the energy escape as much. So an isolated system, ideally, matter and energy cannot escape. But that's not true. You can never have a truly isolated system. You can just try to get close to an isolated system. Okay?